So without further ado, I would like to hand over to Emily Miles, the Chief Exec of the FSA.
Thank you, Erin, and good morning, everyone, and welcome to my spare bedroom in South London. I'm sure we're going to be seeing a lot of people's living rooms and kitchens and spare bedrooms today. It's really, really great that you're here. As Erin said, I'm the Chief Executive of the Food Standards Agency, and this work on infectious diseases, intestinal diseases, is one of the key planks of our work on science. And that's why I wanted to make time to come and say hello to you all this morning. I also want to introduce you to the Food Standards Agency. You may know us extremely well, but for those of you that don't, we're a non-ministerial government department, which means that we don't have a Secretary of State to oversee our work. We report to a board, an independent board. And that is because it was felt that after the BSE crisis, that there had been too much confusion between the interests of government departments, particularly MAF at that time, working to protect the agricultural industry and not putting the consumer interest first. So we are here to put the consumer interest first in food. And we were set up in 2000, so this year we celebrate our 20th anniversary. We work in England and in Wales and in Northern Ireland, so we, although we give advice, it's ministers in those jurisdictions that take final policy decisions. They still have the legislative policy making power, and we give independent and open and transparent advice to those ministers. And then our colleagues at Food Standards Scotland do the same there, and we work very closely with them. The FSA believes that the consumer interest is served when consumers can have food they can trust. So food you can trust is our mission and is part of what we are trying to achieve today. If a consumer can go into a supermarket and buy food that's safe, can go to a restaurant and eat foods that's safe, that helps everyone. It helps them because they don't get sick, but it helps the economy because it means that people trust the food that they're getting. And it also means that you can have that delightful shared experience of eating food and that be a pleasurable thing, not a worrying thing. And that benefit around safe food is of huge, huge importance to us as an economy. We think that therefore the FSA also has to be trusted in what we do. It must be essential that we show our good intent to serve that mission. We mustn't be distracted by political need or economic interest. Food you can trust is the core of what we do. And we also try and improve our reputation and our trustworthiness by operating as transparently as we can, so that the evidence that we use can be debated in the open. We try and listen hard so that our work is informed by what is, not what we imagine to be. And we believe that we're here to tell the truth. We're here to tell the truth about food. We obsess about science and evidence, hence this meeting today. And we're upfront about what we don't know, because we also think that communicating uncertainty is part and parcel of being honest about food. We are actually in the top quartile of government organisations in terms of trust. About 75% of people that have heard of us trust us. That compares to about 38% for government as a whole. So we think that that recipe of good intent, of transparency, of listening and telling the truth is effective at maintaining our reputation, but also ensuring that people trust us so that they can trust the food that they eat. Open and unbiased science is at the heart of what we do, and our new Chief Scientific Advisor, Robin May, who you'll hear from shortly, has recently written a blog about that, which I encourage you to look at. The evidence that we use is transparent. It contains information on the science and analysis underpinning our decisions. And we also, as I said, include any uncertainties or gaps or assumptions in how we use that analysis in our decision making and advice. We also follow a strict discipline between the risk analysis, that assessment of what the science is telling us, and then the risk management, those policy decisions that respond to the science and make judgments about what we think should happen as a consequence of the evidence. So I'm really thrilled that you're all here today to talk about infectious disease. The more we know, the more we can prevent deaths and illness and keep people well, and the more we can have food that we can trust. Science and technology constantly evolves, constantly changes, and the FSA makes it our mission to keep up to date with the latest research. So that's all I wanted to say by way of introduction. I think I'm now handing over to Rick Mumford, who is a professor and also the head of our Science and Evidence and Research Directorate. So Rick, over to you.
Thank you very much, Emily. Yes, so as Emily said, this was my opportunity to introduce a bit more about the science that we do at the FSA. Can I have the first slide, please, Erin? Thank you. So I think the way to describe science and evidence across the FSA can be done in using this sort of diagram, and it describes, if you like, the four areas in which we operate. So at one side we have our own internal science capability, and I'll talk a little bit more about that later. We then also have closely associated with us is our Chief Scientific Advisor, and Robin May's on the call, and Emily introduced him earlier, but also our scientific advisory committees, which I'll discuss in a few slides. We then also have another area of science, which is the work we do with other government departments, but also our national laboratories, and in particular the national reference laboratories, and that's a very important part of the work we do, and they're part of this important national capability that underpins our science and evidence. And then finally, and probably most importantly for this call, is the wider research community and how we engage with them through our research and evidence programmes, a spend of around £8 to £9 million a year. Next slide, please. So if we focus to start with what we do internally, so I am head of science, evidence and research, and we're a division within the FSA. We sit under the science director, who's Julie Pearce. And we provide a range of different functions and services. So we provide expert risk assessment. That's absolutely core to our function. We also provide scientific evidence and analytics to underpin decision making. So that's our capability around economics, social science, operational research, modelling and stats as well. But we also provide all the support and management of the external research and evidence capability that the FSA draws on. So that's our scientific science advisory committees and also our external research and evidence programs. And just out of interest, we have just published our areas of research interest, our ARIs. All government departments have to have these, and we've recently produced a refreshed set that have been published on our website, so you can go and look at those. And these show our priority areas. They show the sort of 11 research programs that we have, but also the sort of gaps in our knowledge and where we want to engage with the external research and academic community. As mentioned, we also support and develop our national science capability, and a key part of this is the 18 national reference laboratories we have in important areas like food microbiology. And then finally, we also have an important function around the delivery of FSA science strategy, governance and assurance, making sure that the evidence that we get is of the right quality to be used. Next slide, please. So I talked earlier about the really vital role of our independent science advisory committees, our SACs, and these sit in a range of different areas. So we have a number of committees that sit across risk assessment, and these are COT, so toxicology, ACMSF, microbiology, ACNFP, which is novel foods, and ACAF, which is animal feed. And then we also have the very important role of the strategic science advice. So this comes from basically from both the Science Council, which work very closely with the CSA and advise directly to the board and the exec within the FSA, but also ACSS, which is our advisory committee on social science. And then also the final bit of the component of the mix is also our regulated products committees or joint expert groups. Again, you can see the subjects there, things like food contact materials, animal feeds, etc. So a very, very important part of our science and evidence. So underpinning the science that we deliver, we have a strategic science plan, and here it is in its very basic form, just showing the sort of very high level areas that we're focused on. So around this area of building science excellence, having the right internal and external expertise that we need, being prepared for the future. We're doing a lot of work around horizon scanning and how we develop that area within the FSA. And also how we grow our influence and impact. And this is really important for us because, as Emily said, trust is vital to the work that we do. Trust in food, trust in the food system is very important. And we can do that through extending our research and evidence activities to make sure that people understand that we are a science-driven organisation. The fourth and one of the biggest areas is risk analysis, and part of that is risk assessment that we deliver from science. So next slide, Erin. So risk analysis is an international term that describes the three-pronged approach to delivering risk, and this has the three components as described here. So there is risk assessment, which is the bit that we do in CERD, which is the science-based bit. And from that science and evidence, we then support colleagues in policy who then do the risk management. They make they work to develop the risk management strategies. But the other third really important component of this is risk communication. How do we explain what we're doing and why decisions are being made? And one of the key tenets of the FSA is about openness and transparency, and it's something that underpins everything that we do. Next slide, please. And this just goes into a little bit more detail about how we use science and evidence in risk analysis. So again, there's this piece around hazard identification, and then it will go into a convoluted and long sort of process of risk assessment, both involving internal expertise, but also involving the science advisory committees, as mentioned. And again, this looks at a whole range of things, characterising the hazards, assessing levels of exposure, risk to health, etc. As well as that, it can also include evidence based on other legitimate factors too, so consumer interest, etc. And then that is delivered through in sort of those packages of evidence, then delivered, as I said, to the risk managers, who will then sort of look at the picture and work with ministers, etc., to come up with those final decisions. And of course, highlighting the role of the Chief Scientific Advisor there, the CSA, and ensuring that we have the senior assurance on the integrity of the science and evidence that's used. Next slide, please. And again, ultimately, when we talk about decision making, it's very key to see that actually risk assessment and science and other legitimate factors and all ranges of different evidence, so consumer interest, economic evidence, technical considerations, have to be weighed up against other options as well. So there is always this balance. And again, the key thing in here is uncertainty, and how can we use research to reduce that uncertainty, but accepting that in all these decisions, uncertainty will exist. And that's a critical part of the consideration. And again, where the openness and transparency becomes really important. Next slide, please. The final thing that I'd sort of like to sort of talk about a bit about and focus a bit more on is this idea of us being a very multidisciplinary team, and the fact that we're very much trying to move towards becoming taking a very interdisciplinary approach to science. So within our own science capability, we have a whole range of expertise: microbiology, toxicology, food regulatory science, stats, operational research, etc. So we have a whole range of capabilities that work together within science, but that also then pulls on other capabilities across the FSA. So veterinary science, surveillance, policy, large amount of digital skills, but also field-based expertise. And we can draw on all this expertise to try and support the things we do. And if I have next slide, please. here's just some last couple of slides are just some really nice examples of how we take this kind of really multidisciplinary approach. And part of this is looking at the whole challenge of foodborne disease and what is the burden on society of that. And again, this is the piece of work where we draw on our expertise and external expertise and research capability in foodborne disease, but then work with our economists and our modelers to develop these models. And again, this stresses the fact that when you look at the burden, you're looking at direct financial costs, those sort of things like the actual personal expenses and rehabilitation, but then you're looking at other indirect costs such as productivity. But then it's also those non-financial costs. How do you put a weighting, a number on things like human costs, things like pain, grief and suffering? And again, there are models and approaches that we can use using things like willingness to pay and Quali's approaches too. Final slide, please. And again, a lot of this is underpinned, that work to develop those sort of models is underpinned by work such as the foodborne disease estimates that we've produced. And again, the latest figures have been published earlier this year, and we talk about 2.4 million people suffering from foodborne disease, and then looking at that in terms of the cost of just over £9 billion as a burden on society. And again, this is the sort of example of where not only is this very interdisciplinary approach that we tried to take, but also the fact that we need the research and evidence that produces the data that drives these types of models. And again, IIED3 will be absolutely one of those critical pieces that will plug into this to help us ensure that we have a real understanding of how important foodborne disease is to the UK. And I'll leave it there. Thank you.
Thank you, Rick. So now I would like to hand over to Paul Cook to give us a bit of background on the IIED project.
Good morning, everybody. And Rick has set out really the issues around infectious intestinal disease and foodborne disease, and really the IIED projects, and this is really work that dates back well over 25 years, have been very, very fundamental to underpinning this work. A lot of additional work has been done following the IIED studies, which has helped to develop the estimates that Rick showed in his last slide, and much of that has been through additional research projects that have been funded and work by particularly the analytics team in the FSA working with external researchers. So I'm going to turn things back a bit now. So if I could have the next slide, please. So just to sort of set things off, infectious intestinal disease, what are we talking about here? Well, IIED, or infectious intestinal disease, presents as diarrhea or vomiting, although those are the main symptoms, but there may be a whole range of others, as was observed in the first IIED study. In the UK at least, IIED is usually self-limiting, but obviously in many parts of the world it's a much more serious event and obviously can be life-threatening. It does have a high cost, as Rick has illustrated, and obviously IIED can, unfortunately in some circumstances, lead to mortality. It's caused by a very wide range of organisms, and we'll come on to see that a bit later. Broadly, bacteria, viruses and protozoa. And transmission for IIED can occur through a number of different pathways. Person-to-person transmission, very common with something like norovirus, foodborne transmission, and also environmental sources, which can include water or contamination, fecal contamination. The issue of IIED is quite complex when you start to look at other terms that are involved in this area. So if we think about gastroenteritis, IIED and foodborne disease, and I haven't included infectious gastroenteritis on here either. You can see that in terms of causes for some of these things, some things will fall outside of IIED, so irritable bowel syndrome, food intolerance, alcohol can all result in some symptoms that may mimic IID, but they're not IID as such. They're not infectious causes in that sense. We obviously have organisms that do cause the typical symptoms of IID, such as Salmonella, Norovirus, Rotavirus and Campylobacter, but not all of these are completely foodborne necessarily. We also have conditions that can be foodborne disease, but are not necessarily, strictly speaking, IID. So, for example, chemical causes such as histamine poisoning. Listeria rarely causes gastrointestinal symptoms, and some viral infections like hepatitis A and E and botulism, again, very rarely cause gastrointestinal symptoms. So how is IID detected and reported? Well, normally a case is only detected if somebody goes to a healthcare provider such as a GP, or they might even present to A&E if it's serious enough, or they may contact one of the online services like 111. An individual might also contact their local environmental health department if they suspect that they've had food poisoning, for example, from eating out. But in not all cases will a sample be sent for testing. There is a balance to be struck between the cost of sending things for testing and also the likelihood of getting a result, and also issues around the timing of when that testing might be done. So a consequence of this means that in many cases of IID go unreported, and even when diagnosed and reported, attributing it to a source can be difficult. So, for example, if somebody reports to a GP, they may not take a specimen, but they may make a food poisoning notification. There's a requirement to notify food poisoning, but interpretation of the statistics for this are difficult and challenging, because there may be underreporting or over-attribution to particular causes. So a consequence of this is that there are various losses to the system at different points, and this can be visualized in a reporting pyramid, although some people prefer to use overlapping ellipses to illustrate this. So if we think of the pyramid, the bit at the top is what national surveillance sees. So this could be your laboratory reports of Salmonella, Campylobacter that we're all familiar with. But if you look at the bottom of the pyramid, you've got people in the community. People may have symptoms, they may not have symptoms, but they may be infected. And we saw in IID1 that some people that were perfectly healthy had actually evidence of infections. So symptoms may be mild and resolve quickly, so people may not actually contact healthcare providers. People may go to a GP with IID and they may get sampled, but they may not. The GP may decide not to take a specimen based on their assessment of the person. Of course, if they're tested, there's no guarantee there'll be a positive result. So, for example, if someone is late going to the GP, you may miss the point by which the organism can be detected, or it may be that something that's not routinely tested for. So, at each stage, we're losing bits of information, and really the purpose of the IID study was to try and understand the relationship between these different steps in the pyramid, or the ellipses, as some people call it. Now, it all started really with the first infectious intestinal disease study, and this arose out of a recommendation from the Richmond Committee in 1990. The study was done over a period of 3 years, and only in England. It was funded by the Department of Health at the time, and it estimated 9 million cases of IID annually, or 1 in 5 of the population in England. 37% of samples had a target pathogen, and a very wide range of organisms were looked for, including bacteria, viruses, and protozoa. Campylobacter and Norovirus emerged as the main pathogens as a result of this study. What it did include as well, which I think was quite ambitious at the time, was a control component. This was to try and understand risk factors for exposure to IID. The control component enabled some case control studies to be done, but the interpretation of those findings were quite challenging. The estimated cost of IID, which was done as part of the study, amounted to 750 million per year, with 36% to the NHS, 55% to employees, and 8% directly to the case. So moving on to IID2. Next slide, please. So why did we undertake a second study? Well, the original study by that time was more than 10 years old. The FSA was formed in 2000, had set some ambitious targets in terms of reducing foodborne disease. Certainly in the first 5 years of the agency, there was a big push in terms of reducing foodborne disease with the aim of reducing by 20%. The data that had come from the IID1 study, plus additional work done in the intervening period, had informed FSA work to estimate the burden of foodborne disease. But time obviously moves on and there are changes to various systems, and we needed to understand the changes in the reporting pyramids. So, for example, the rates of GP consultation, requests for lab samples, reporting to national surveillance, how structural changes in national surveillance might have impacted on the reporting. There was also the issue of the application of new microbiological methods. There were really increasingly molecular techniques coming on stream that could be applied. So, for example, in IID1, a lot of the viral work was done using electron microscopy, whereas now we have the tools of using PCR for many of the viruses. And obviously the data would help to inform new foodborne disease estimates. So the main questions that were posed at the time in terms of the policy relevance, which was to aim to reduce foodborne disease further, was, has the instance of IID in the community fallen since the mid-1990s? Have the relationships in the reporting pyramid changed? And to compare the microbiological findings between IID1 and IID2. So the overall aims were to estimate IID in the UK, and the point here is that the IID1 study was done in England, but obviously we wanted to do it on a UK-wide basis to estimate the rates for individual pathogens and show whether the overall IID had changed since IID1. It was not designed specifically to show whether the rates in individual pathogens had changed. That would have required probably a disproportionate amount of statistical power to deliver that, and also differences in IID between countries in the UK. Other key differences, I say it was UK-wide. There was no control component included on this occasion. And now it's slightly narrower range of target organisms. We learned from IID1 that some organisms were pretty insignificant in terms of the findings at that time, but we also had the benefit of new methods that could be applied in IID2. The economic cost analysis was not included on this occasion, but subsequent work has led to that development. Obviously, structural changes included the advent of things like NHS Direct and NHS 24 at the time, so there are other means of healthcare contact. And something that we included on this occasion was a telephone survey in IID2. Obviously, doing these studies every 10 years or so is very resource intensive, and in some other countries, telephone surveys had been used quite successfully to monitor IID in the community, and we were interested to see whether this was a potential way of looking at IID on a more regular basis. Thank you. Clearly, one of the key things when you do this type of study, particularly where you want comparability is to ensure that you have a consistent case definition. I've already alluded to some of the challenges around what IED is compared to other gastrointestinal situations, and the definition used was the same as in IED 1 to give that comparability. So persons with loose stools or clinically significant vomiting lasting less than 2 weeks in the absence of a known non-infectious cause preceded by a symptom-free period of 3 weeks. So the intention was to exclude non-infectious causes of diarrhea and vomiting. Next slide, please. In terms of sample size, we wanted the ability to detect a 20% change in incidence, and this was framed around severe cases with 80% power and 95% precision. That resulted in the collection of 84 GP practices distributed across the UK, as shown in the slide here, with each practice recruiting 100 cases. As I said earlier, if we were to base it on individual organisms, then the number of person years and GP practices would have risen very substantially, and it just would not have been practical to do the study at that time. Next slide, please. So it was quite a complicated structure to the IED2. There were 7 main studies. There was a retrospective telephone survey, but most of the work was around the prospective studies, and this included a cohort study looking at community, GP presentation study, a validation study linked to that presentation study, and a GP enumeration study looking at current clinical practices. The microbiology involved both routine testing using conventional methods and also the state-of-the-art tests using the new on-stream molecular tools. Based on the findings, there was then a calibration study looking at how the findings compared to national surveillance. Next slide, please. So we could just go down till we've got them on screen. Thank you. Next one. Thank you. So yes, so these just to illustrate some of the main ones here. So the population cohort study was to estimate the incidence and etiology of IED in the community. They had individuals had weekly reporting cards or by emails, and submitted a stool sample if they had an incident of IED, and that was over a 1-year period. GP presentation study, people obviously accessing healthcare. The enumeration study to look at the proportion of samples routinely sent for tests and their results, and then calibrating the data to national surveillance. Next slide. So a wide range of target organisms were looked at, and this just gives a flavour of a mixture really of using traditional culture-based methods, immunoassays. Light microscopy was used for the parasite Cyclospora, but a lot of organisms were looked for in terms of molecular testing. They didn't look for the full range of E. coli that were looked for in IED 1. In this occasion, obviously E. coli 157 was tested for, but also enteraggregative E. coli and VT1 and 2 producing E. coli as well by molecular tests. Next slide, please. So it just gives a profile really of what was found in terms of the organisms in both the cohort study shown as white bars and the GP presentation study shown as the black bars. And you can see, I think, on the left-hand side, Campylobacter was by far and away the most important bacterial pathogen, and also the one presenting to GP presentation, but also in the community as well. On the right-hand side, this is dominated by viruses, which overall dominated the microbiological findings, and particularly norovirus, and to some extent sapovirus, which was perhaps a little bit unexpected or unanticipated, but there was an emergence of a particular strain at the time which may have accounted for that. Next slide, please. So one of the questions really was, if we've now used these new molecular tools, has it reduced the diagnostic gap? In other words, using a wider range of tools, are we picking up things that wouldn't have been detected using more conventional microbiology? And the answer to that is yes, although perhaps the uplift, if you like, between ID1 and ID2 is not as great as perhaps might have been anticipated, although this is complicated by the fact that there were more bacteria looked for in ID1 than in ID2. However, the estimate was that there was around about a 10% uplift in terms of applying the molecular tools in ID2. Next slide, please. So in terms of the overall findings from the study, there were 17 million cases of IID per year in the UK, which equates to around 1 in 4 of the population. 3 million of these were norovirus, 500,000 were Campylobacter, and 40,000 Salmonella. When we look at general practice, again, norovirus dominates, Campylobacter 80,000 and Salmonella 12,000. And there were obviously there was implications in terms of lost days, in terms of school or working, equating to 18 million or 11.4 million in people of working age. Next slide, please. As I indicated earlier, ID1 was conducted in England, so there was an opportunity to compare the results of ID2 in England with ID1. And this showed that the rate of overall ID in the community had increased by 50% between the two studies. But contrastingly, the rate of ID presenting to primary care, predominantly GP practices, had halved. There were also changes in the ratio of cases reporting to national surveillance. So, for example, in ID1, for every one case reported to national surveillance, there were 85 in the community, and in ID2, for every case reported, there were 150 in the community. And when you look at the individual organisms here, there was a bit of a change in terms of Salmonella, not much change in terms of Campylobacter, but norovirus went from 1 in 1,000 cases being reported to national surveillance to 1 in 300. Next slide, please. So turning now to the ID2 extension, obviously ID doesn't tell us definitively what burden is foodborne. So additional approaches are needed to try and tease out what proportion of the ID is actually attributable to foodborne disease. So the intention here was to try and determine foodborne disease that is UK acquired and to estimate the burden of foodborne disease caused by contaminated food commodities. And for this, a point of consumption attribution model was used. Next slide, please. Now, a lot of studies are published in the literature on attribution using different approaches, but a combination approach here was used, relying on a number of different data sources. There was a systematic review of the literature, and 8 attribution studies were used as part of the data sources here. We also had a rich data source of outbreaks from national surveillance centres in the UK, to amounting to 446 outbreaks, which could be mined in more detail. We had the data from ID1 and 2 on the reporting rates. We also in the UK have the National Diet and Nutrition Survey, which gives us consumption data. One of the challenges in this area is actually classifying your food commodities. This may seem straightforward in some instances when we talk about milk or we talk about poultry meat, chicken meat, for example. But of course, many foods that are consumed are are multi-complex foods, combined different types of foods. So something like egg, for example, may end up in various dishes, as opposed to the single shell egg itself. So there was a need to try and standardize the categories that were going to be used for comparing these food commodities. And one of the interests here was to conduct modelling to try and get some measure of uncertainty associated with these estimates. Previous estimates had been more or less point estimates rather than being able to express uncertainty. Next slide, please. So I've illustrated here really some of the findings from this work, and at the bottom of the graphs give the overall figures based on the Monte Carlo simulation results. The results for the other Bayesian methods were broadly similar in terms of their findings, so I've just included one here. So overall, it estimated 566,000 cases of foodborne illness in the UK in 2009, 74,000 GP consultations and 7.6 hospitalizations. Now we have the pathogens listed down the right hand side here, and these are shown in different colours. Unfortunately, a little bit small to see the details, but the real message is here. If you look at the brown bars, which relates to Campylobacter, the dark brown bar, you can see that makes up a substantial proportion of the foodborne disease burden, both in the community and also presenting to GP consultations. It falls in terms of proportion, in terms of hospitalizations compared to others, but still significant. Contrastingly, the light blue relates to Salmonella, which obviously there are far fewer cases in the community and reporting to GPs. But in terms of hospitalizations, Salmonella was important. The same also applies to the purple, which is E. coli 157, which obviously important in hospitalization. Next slide, please. And if we look at this in terms of food commodities, again, the brown, which is the bottom part of the bars, that relates to poultry meat, perhaps not surprisingly, because that obviously tends to be linked to Campylobacter, but other food commodities also make a contribution. So for example, eggs, the light blue, that is obviously important in terms of the hospitalizations, linked again obviously to Salmonella being one of the pathogens which is more significant in terms of hospitalizations. Next slide, please. So what about the strengths and limitations of this? Well, one of the advantages is the availability of directly observed pathogen-specific instance data from the IRD studies. The approach, I think, was novel in using outbreak data from a number of sources, including systematic review of published studies. There are some challenges with using outbreak data, and in fact the outbreak data is declining over time, so that's one of the factors that will need to be considered going forward with this. There is uncertainty associated obviously with food commodities. Some of the data that was used here was from a variety of different sources, and that does make challenges in terms of combining it for this type of analysis. And one of the challenges is that a particular food may be a source of infection, but it's not necessarily the vehicle. So for example, you may have cross-contamination of Campylobacter from poultry to things like salad. So people get sick from the salad, but actually it came from the chicken. Next slide. So the conclusions from the ID2 extension were that Campylobacter remains the most common foodborne pathogen in the UK. Other common foodborne pathogens are perfringens, norovirus and Salmonella. And contaminated poultry meat was by far and away the most common contributor to foodborne illness, but other important food vehicles included eggs, beef and lamb, seafood and produce. Remember that these conclusions are based on analysis of data that relates to 2009. So we're more than 10 years on from where these estimates relate to. Next slide, please. Now, there are a number of research recommendations in the IAD2 extension. I haven't included all of them here, but I just wanted to highlight 3 of them. The need really for better estimates of hospitalisation, including the length of hospital stay, and also deaths from foodborne disease in the UK. The deaths didn't form part of the analysis in this study, but there has been subsequent work to try and tease that out. It is particularly challenging, particularly when people have other underlying conditions, and trying to estimate what the contribution of the pathogen is to their death. Estimates of disease burden and costs to help prioritise food safety policy measures, and the need to take into account long-term sequelae. Again, work has been done in the intervening years to try and plug some of this gap. Perhaps the one that's going to need to be considered going forward in particular is the need for better data to be able to attribute illness to foods and to perform food commodity attribution. There will be a need for alternatives to over-reliance on outbreak data, which is declining. So opportunities to look at approaches such as expert elicitation in the UK context, case control studies for sporadic illness and molecular subtyping could perhaps be explored. The WHO estimates of foodborne disease, for example, used expert elicitation. And finally, I just wanted to highlight a project that's just been finished this year, which was looking at the methodologies used to estimate foodborne disease in the UK to those used in other countries. And there's a comment here from that report that the IAD1 and IAD2 studies in the UK were the only prospective cohort studies using the same methodology repeated at different points in time in the same country. They were the only 2 studies where the pathogen-specific estimates could be compared over time. Next slide, please. So I'll finish by just mentioning that the reports that I've discussed are available on the FSA website. There's a lot of reading material there, so but please do have a look at those. They're very useful, I think, in formulating your thinking on how you might approach this. Thank you.
Thank you, Paul. Yeah, a brilliant overview to the IAD 1 and 2 studies there. So moving forward, I'm going to give you a brief introduction to the IAD 3 study. So IAD 3, why are we doing IAD 3? Well, much in the same light as IAD 2, it has been over 10 years since we last did one of these studies. The data collected in IAD 2 will have been affected in the same way as the data in IAD 1 was, by things like the national surveillance, recommendations to consumers on when to go to a GP, and also recommendations to GPs on when to take samples. And in addition, there may be changes to what is routinely screened for in microbiological screens. So we need to update the reporting pyramid to allow a more accurate estimation of the burden of IID in the community. So what is the key focus and aims of IAD 3? So we want to focus on the cases and GP presentations of IID in the UK, the ratios of domestically and non-domestically acquired IID, the etiology and proportion of IID per pathogen, and this very importantly will include the unknowns. So those that we don't know the cause, those cases of IID where we don't know the cause. In addition, we want data on the underreporting rates of each IID causing organism. This will allow us to update that reporting pyramid And all of this is kind of on overlapping with what was collected in the IID2 study. But in addition to that, we wish to look at the prevalence of AMR genes within foodborne disease or IID in the UK. This is a new part of the IID3 study that falls in line with the FSA's contribution to the AMR National Action Plan. And as well as that, we are combining that extension to the IID2 study into the main study in IID3 to give some more continuity to the results. So we would expect that data on the economic burden of IID in the UK would be collected, and that a model of both IID and foodborne disease, split by both commodity and pathogen, would be created. This can either be based on previous models that the FSA have got, or could be an entirely new model, depending on the contractor. But this will look at the number of cases in the community, the GP reported cases, the hospitalisations and deaths attributed to IID. So the study design. The IID study will include, the main component will obviously be the prospective cohort study. The FSA has recently published some literature showing that prospective cohort studies are the best way to estimate foodborne disease, and we would be silly not to make use of it again. In addition to this, we would want to, a way of measuring the primary care presentations, the economic burden, and we would want, in line with IID2, microbial analysis, using both those microbiological methods and PCR methods used previously, but also potentially using novel methods and techniques where available. We're hoping that a component of the study will be a metagenomics study, and we will want the creation of that food attribution model, as previously mentioned. Additionally, although we're not doing a telephone survey in the IID3 study, it is desirable that this study will include some sort of social survey of the self-reported IID in the community, whether this be in the form of a web or app-based method. It will be interesting and informative to the FSA to see whether that could be used as a way to look at IID between years of IID main surveys. So the cohort study, as in IID2, this will be a UK-wide representative population based on the cohort. There will be a duration of at least 1 year, and it will monitor for IID, and those that are showing symptoms will be asked to submit stool samples. It will then collate data on the symptoms and other health data, including costs associated with the economic burden of disease. The sample size of this cohort study will allow for 95% confidence bounds to be within 10% of the estimated rate of IID and 20% of the estimated rate of GP presentations, and should be able to detect a 20% difference to IID with an 80% power. And the design should, we're happy to have a novel design, as long as the contractors can outline how this will be comparable to previous studies. So what are we expecting in terms of the economic burden? So there are several factors that we would expect to be collected in terms of the economic burden associated with IID. And these are both long-term and short-term. So the long-term are looking at things like the proportion of cases that go on to develop a long-term illness, the age profile of those that do, the healthcare resource usage for those that do go on to get that long-term illness, and what their frequency and length of absence from work will be. As well as that, there's potentially other related costs, for example, the cost of dietary restrictions, avoidance of restaurants due to long-term sequelae. And then the short-term illness We would want data collected to explore differences in the decision to seek healthcare based on the population. So who is more or less likely to present to a GP? Information or data from individuals that do seek healthcare, for example, going to that GP, on what testing was undertaken and how they were treated. And then additionally, information on the on those not seeking healthcare, on what treatment or over-the-counter medicines they used. In addition, other expenditures, including individual expenses, would be included. So, for example, special food or drink, cleaning materials or products used within the home, and the potential for childcare costs if children are ill. So as part of the main cohort study, fecal samples will be collected, and these will need to be tested for the key causative agents of IID. This will allow us to determine etiology, and the key pathogens that we would expect to be screened will be broadly similar to those undertaken in IID2. We are hoping for potentially some level of strain level identification, whether that is through traditional methods or whole genome sequencing. And we would also expect that there will be an additional subset of these samples which will undergo metagenomics to undertake and determine the AMR burden. So the metagenomics portion of the IID study, as I said, will be on the fecal samples that were collected as part of the IID cohort study. The analysis will not only inform us on the members of the gut microbiome, and for samples with no known etiology, potential causes of IID may be highlighted in this data. But the samples should also be screened for antimicrobial resistance genes. Key consideration should be given to the study design, the inclusion of samples, and potentially inclusion of samples from patients without IID symptoms, so some sort of control group. In addition, consideration should be given to general controls, data analysis techniques, data quality assurance, and the storage and analysis of data and metadata from this study. And finally, a food attribution model will be created. This will model the foodborne disease acquired in the UK. Data inputs can include previous IID studies, data from peer-reviewed literature, expert elicitation studies, and also there is a wealth of data from previous FSA projects, such as the norovirus project. The model should examine both pathogen and food commodity, looking at the source attribution of IID, the underreporting, the cases, hospitalizations and deaths, and also should take into account those of unknown etiology. And now I'm going to hand over to my colleague Mark Croft to give us a little more information about the timelines and procurement processes for IID3.
Good morning, everybody. As Erin says, my name is Mark Croft. I'm the Commercial Category Manager at the Food Standards Agency for the Science and Evidence category. As such, I'll be supporting Erin and the team through the pre-tender, or this pre-tender stage, and will continue to do so right through the invitation to tender, on through the evaluation of the bids and right into managing the subsequent contract. Next slide, please, Erin. So in terms of the timelines that we anticipate for the tender process, given the value of the contract, we will be running the tender as an EU-wide open tender exercise, which a lot of you will be familiar with. I'll talk shortly about where the opportunity will be published and how you can access the full documents. Our current plan is to publish the tender in mid to late October, when all the documents are ready. Procurement rules, EU and British procurement rules dictate that we leave the tender open for a minimum of 30 days. That's obviously a given, and the intention will be, as it shows on the rough timeline, this subject to change, that it'll stay open for longer than that, for possibly up to 2 months or more. And that allows obviously for the complexity, also allows for the fact that the timing of the exercise will mean that we're running across the Christmas period. Obviously, if the government don't cancel Christmas later today, but and so approximately we expect to be reaching late January when we expect responses to be returned. Following that, approximately February, we would expect to be carefully evaluating the bids through our normal evaluation processes, and all being well, being in position to notify the outcome by about March time, March 2021. Next slide, please. All right. So in terms of evaluation of tenders, this slide is just an example of our evaluation criteria that we'll be using. It may not be exactly like that by the time we do the final version. Obviously, it's subject to change, but those are the fairly standard criteria that we use. Our response templates are actually based on those criteria, and we'll follow that sort of layout in terms of approach, scope of work, plan and deliverables, project management. Again, a format that a lot of you will be already familiar with from past bid processes. The weightings on the right hand side clearly dictate the relative importance of the marking, so vary from, on the example shown, from 20% to 10%, but may change again. Financial criteria carries 20% of the marks. You'll also be provided with a template to provide a full breakdown of costs, including subcontractor costs, when we submit the tender documents. Next slide, please, Eric. Okay, how do we evaluate bids? So against each of the criteria that we showed on the previous slide, we go through an evaluation process which follows marks through 100, 80, 60, 30, 0. Clearly that's going from 100 where we the response fully meets our needs, right through to 0 at the other end of the scale where it doesn't really provide any evidence. The note at the bottom could be important because in some tenders we do reserve the right to provide a minimum, expect a minimum score in all criteria. So the impact of that is that if, for instance, if we say that if you score less than 60 on any of the criteria, that becomes a fatal criteria and you are effectively eliminated from the process. If we do apply that, then it will be made absolutely clear on the specification. Next slide, please, Erin. So I mentioned that we would be publishing the ITT, and I would say where we're publishing it. We've 3 main sources, really. One being our e-procurement system. Again, many of you will be familiar with that. It was known as Bravo, now Jaeger. And if you are registered on the system, you'll be used to being notified when opportunities come up. So that's the first source. The second source is actually called Contracts Finder, but it's the government's transparency website. So you can register on that site so that you're notified of any opportunities that arise across government that you might be interested in. For instance, you can log in and register interest in research work, and you will automatically be notified of opportunities. So we will be advertising on there. And thirdly, Tenders Electronic Daily is the European site. I mentioned that it will be an EU-wide tender. That is the site where we publish opportunities that are available across Europe. So each of those sites will will include our tender, and with each of them you can register your interest in them. So if you receive the specification, or you see the specification and you're interested, or you see the opportunity on Contracts Finder, etc., what you need to do is register your company on the FSA sourcing portal. Like I said, many of you will be already registered on there. If not, you can register at any time. Once the opportunity is open, all you need to do is click on the PQQs, which is a PQQs open to all suppliers, which you'll see on the first screen, and it'll link you into the current opportunities that you can see, including this one. And all you have to do is click that you want to express an interest, and you will then be able to access all the documents that are available to you. So if you do run into any technical problems, oh, sorry, Erin's kindly put up the next slide, which actually is on our food.gov pages, which you can link either from that slide or from food.gov to our e-sourcing tool. So if you're struggling to find it, that'll give you a link in. As you get into the tender process, myself and my colleagues will always be willing to help you with any system problems. The last thing we want suppliers to be constrained by is our e-procurement system. So we're absolutely willing at any time to talk you through the any difficulties that you might have, and make sure that you're able to get all the support you need. And apart from that, it's just good luck with the process. Like I say, we're here to help.